Hi everyone. We have the 20th lesson for algebra. Today I want us to look at quadratic formula. Quadratic formula is one of the renowned methods that we use to solve a quadratic equation. One of the reasons we use quadratic formula to solve the quadratic equation is when we notice that there are no possible factors to solve the particular quadratic equation. So we can choose to use either the quadratic formula or completing the square method. Okay, sometimes the question paper will say if ax squared plus bx plus equal to 0, then show that x equal to this. But once we talk about quadratic equation, this is the standard form, this is the general form. So it's something that you need to be able to remember, you need to be able to write without even being informed. Sometimes they will not even give you this. They will only say, prove or show the quadratic formula. All right, so let's start the proof now. Now, if ax squared plus bx plus c equal to 0. Now, first of all, let's say x squared minus 3x plus 1 equal to 0. This is one of the quadratic equations that we cannot solve by factorization. It's not possible. So unless we think of either quadratic formula or completing the square method. So some people or some students are not aware that the renowned quadratic formula is derived using completing the square method. So in other words, completing the square method is more fundamental as compared to quadratic formula because we use completing the square method to derive the quadratic formula. So let me take you to quadratic formula derivation. So the first thing we do is to move the constant term to the right hand side. So we say ax squared plus bx equal to minus c. We have moved the constant term to the other side. What is next? The next thing is make sure that the coefficient of the squared term is 1. And the coefficient here is not 1. What makes it not to be 1 is a. So use that a to divide throughout. So use a to divide every term. So a takes away a. So we are left with x squared plus b over ax equal to minus c over a. I hope you are getting it. Now, first, move the constant term. So if you understand today what we are doing, guess what? You have understood completing the square method equally because the same steps, everything is just the same. 1, the constant term has to go to the other side. 2, we want the coefficient of the square term to be 1. Because it was not 1, what was there is what we used to divide throughout every term. What is next? The coefficient of x. Coefficient of x is, what is the coefficient of x? Is b over a. B over a. So this b over a, what do? We multiply it by half and square it. So once we do that, b times 1 is b, a times 2 is 2a. I hope you get it. The coefficient of x, not x squared, the coefficient of x is b over a. This b over a, multiply it by half. Multiplying it by half is a fixed concept. Squaring it is always done. This is what we do. I know you can say b squared over 4a squared, but this is not the right time. So what is next? So we say add b over 2a squared on both sides. We add this one on both sides. So if we are adding this on both sides, the left hand side is x squared plus b over a x, and the right hand side is minus c over a. The right, look at it. The left, look at this. And we want to add this on both sides. So say plus b over 2a that we have decided to add, plus b over 2a. I hope you understand what we are doing. All right. So what is next? We expand this, but we don't expand this. Let's see the magic here. This one we have here, x squared b over 2a squared. See the pattern here. X, look at it. Oh, sorry. Okay, this is b over 2a. Okay. Now, x squared plus b over ax plus b over 2a squared. This one will give us one bracket. How do we go about it? What is the base here? Is x. What is the base here? Is b over 2a. But is it positive or negative? It is positive. See? Forget about this. Don't worry, it is part of the magic. The base here is x. The base here is b over 2a. So x plus b over 2a all squared. We are done with the left hand side, which is equal to minus c over a minus c over a plus. When the square affects b is b squared. When the square affects 2a is 4a squared. So b squared over 4a squared. I know you don't want me to continue. You want me to explain why we decided to forget about this. Is that not so? Now let's see it. Now what did I say? This base is x. This base is plus 2b over 2a. Just take this base and this base, compound it and say square. This is part of it already. Let's see it. So if we expand x plus b over 2a squared, it's like writing this one twice. X plus b over 2a. X times x, x squared. X times b over 2a, bx over 2a. b over 2a times x, bx over 2a. b over 2a times b over 2a, b over 2a squared. So this is x squared and this is b over 2a squared. If you have 4 plus 4, what do we say? We say 8. Don't you know that it is like 2 sets of 4? 2 sets of 4. So if we have bx over 2a, bx over 2a added, so it's like we have 2 sets of bx over 2a. Just see, this takes away this. X squared, bx over a, or b over ax, b over ax, b over 2a all squared, b over 2a all squared. Do you see it? All right. That's why I said it is already part of the magic. So we say x plus b over 2a all squared. What do we say here? So let's see here. 3 plus 5 is the same as 5 plus 3. This plus this is the same as this first before this. So this is b squared over 4a squared. Now this c over a. Just be attentive, please. So what is next? We say x plus b over 2a. What is the LCM here? The LCM is 4a squared, because this can divide this without a remainder. This can divide this without a remainder. So 4a squared into 4a squared is 1. 1 times b squared is b squared. Minus is this. A into 4a squared. a into 4a squared means a takes away 1a. What will remain? If this a takes away 1a, there will remain 4a. There are two a's here. This one takes away 1, there will remain 4a. So that's 4a times c, 4ac. 4ac. Okay. Now let us go to another concept that says x squared equal to 9. So this x squared equal to 9, what do we say? We ignore the square and take the square root of 9. So if this is true, we ignore the square and take the square root of the other side. So here again, x plus b over 2a. We ignore the square and take the square root of the other side. So this is b squared minus 4ac over 4a squared. I hope you get the point very, very well. Let us go to another argument. What is the square root of 9? The square root of 9, they always say 3. Have you ever asked yourself why the square root of 9 is 3? I hope you know it. The square root of 9 is 3 because 3 times 3 is 9. The square root of 9 is 3 because 3 times 3 is 9. Now, don't you know that this argument can give you something else? You are saying the square root of 9 is 3 because 3 times 3 is 9. So if I say x times x is 9, will you accept that the square root of 9 is x? Because according to the argument, the square root of 9 is 3 because 3 times 3 is 9. So meaning whatsoever that multiplies itself to give 9, we accept it to be square root of 9. So what if we say minus 3 times minus 3? I go again. The square root of 9 is 3 because 3 times 3 is 9. But this is not only what will give us 9. Even minus 3 times minus 3 will give us 9. How? Minus times minus is plus. 3 times 3 is 9. So the square root of 9 is not only 3, it is also minus 3. Because of that, the square root of any positive number is plus or minus. If you have been seeing plus or minus in the quadratic formula, this is the reason we have plus or minus. So in that case, x plus b over 2a is equal to plus or minus. Down here is a perfect square. At the top, not a perfect square. So since down here we have a perfect square, which is what? Square root of 4 is 2. Square root of a squared is a. So the root only stops at the top. B squared minus 4ac. You see it? So we need only x. So if we need only x, this one has to go to the other side. So plus or minus the root of b squared minus 4ac over 2a. Then this one goes to the other side, minus b over 2a. I hope you get it well, eh? All right. So now we say x is equal to the, okay, let me go at the top. The denominators are the same. So since the denominators are the same, what do? We take 1. So x is equal to plus or minus the root of b squared minus 4ac. Because the denominators are the same, so we just take 1. Then we take this minus b. Minus b. Do you see that? I hope you see that. Now, what if I tell you that minus 5 plus 3 is the same as plus 3 minus 5? Likewise, plus 3 minus 5 is the same as minus 5 plus 3. So therefore, this can also be written as bringing the b first. So minus b plus or minus the root of b squared minus 4ac over 2a. So this is the quadratic formula for you. Thank you for watching. Don't forget to follow, like, share, and comment. Also subscribe to the YouTube channel. See you in my next video.